Hello. So this is a video about how do we design solutions using model-based, reflex-based agent architecture. By the word model, we mean that the environment in which the agent is supposed to learn. By this time, we believe that students have understood the concept of rational agent. How do we do Bayes analysis when the problem statement is given and analysis of properties of task environment. After going through this video, students will be able to understand various characteristics of model based reflex agents and they would be able to apply the concepts to design the solutions using the reflex based architecture. Here we have taken example of autonomous traffic light controlling agent in smart city. This particular traffic light controlling agent is supposed to react to reflexes. Hence, let us go with Bayes analysis first of all. P stands for performance measure and has to be measurable. So we have to start with some scale and accordingly for good actions we should give reward and for bad actions we should give penalty so that at the end of every run we will be able to analyze performance of the system. Here are some example criteria and for them we could give some rewards and penalties based on the actions chosen by the agent. For example, for traffic congestion reduction, if it is able to reduce the wait time, then we can give the reward. While as for every time the wait time increases for some amount of time, we can give some penalty. Also, apart from the scale, we can give some extra bonus whenever the agent performance better. Going ahead with P's, the environment actuators and sensor. Here, for the traffic light controlling agent, the environment would consist of different road and road networks, different types of vehicles. Those vehicles may have different speeds and behaviors. There might be pedestrians, there could be special events causing roadblocks, and so on. The actuators the agent has are the traffic signal lights with which it will be able to communicate with the environment. Some digital signage displays to inform the drivers how long they are supposed to wait before the light turns red or green, etc. For all this, it is going to receive the input through the sensors such as traffic cameras, the loop detectors to count and measure the vehicle presence and the speed, then pedestrian sensors, some special sensors for noting the presence of emergency vehicles, and so on. After the piece, one must understand the properties of task environment related to this particular task. Here, we believe that the agent is supposed to react to the reflexes, read the sensor data, and take the actions. As we are considering all the sensors, this could be a fully observable environment giving the current scenario at the junction, and accordingly, the traffic lights would be turned red, green, or something like that. The environment is also deterministic as given the state and chosen action, the next state can be predicted. For example, display of red signal will mean that the vehicular flow is going to stop and on the green light they are going to go ahead. The actions taken at one moment are going to directly affect the future states of the environment causing the traffic flow or queue buildup and hence the status of this episodic versus sequential is going to be sequential. While the agent is acting, the environment is going to change and hence it is dynamic. The number of states, actions, and percepts are infinite, making it continuous. And this is a multi agent environment wherein the other vehicles, pedestrians, etc., are going to be moving characters in this particular one, making it multi agent. As we are not expecting it to be very intelligent one, even if it reacts to the reflexes, the work of traffic light management could be done. Hence, the reflex based agent architecture, we have to understand what all elements are there and accordingly what goes in each one of the blocks. So let us see the sample contents of each one of the blocks in this architectural diagram. How the world evolves is the most important part of any agent architecture. Here, the word evolution information with and without the agent is important. Hence, we have to detail the concept of road, different road widths, then different roads have different traffic flows, definition of high traffic and low traffic, how do we understand the signal and signal durations, the traffic patterns, etc. The pedestrians, how uncertain they are, how the pedestrian flow might increase or decrease during the day or near the school and all, impact of green light duration on traffic flow, the traffic speed, and what are the emergency vehicles and why do we need to clear path for them, etc. Going ahead, the next block is what my actions do. So, given the actuators and sensors, the agent will be able to change the signal state, change the green light duration based on the traffic flow, enable pedestrian crossing, etc. All the actions it can do. We have already detailed the environment, so some of this part is being repeated. The state and internal state combination is going to give us information regarding how the world is like right now. The internal state is going to be part of the percept history, which combined with state of the current percepts would give us information on how do we interpret the current scenario and which action should be taken. When we come to the reflex based agents, they react to the reflexes. So, for that we have to detail the conditions and the corresponding actions for them. So, for example, a pedestrian is detected near crossing, then schedule the pedestrian crossing signal to activate after the current green light cycle ends. If there are no pedestrians, then probably don't turn them on. Or traffic flow is below normal during off peak hours, then the agent could reduce the green light duration to save energy and minimize idle time. So, this way we can enumerate some conditions and the probable actions for them. The next block is what action should I do now? It totally depends on the current state received through the sensors. Also, it combined with the earlier percept history gives us more information. For example, right now we see that there are more traffic waiting at the intersection, and also earlier as well there was a lot of traffic. That means it is rush hour and probably it could work for the rush hour condition action rules rather than off rush hour and so on. Knowledge of how the world evolves, condition action rules matching in the agent program. Considering all this, the agent is going to take the action. Let us consider one of the problem instance wherein we are considering a normal regular day. There is a divergence scheduled due to a marathon and flow of emergency vehicles due to some mishap is supposed to be there. So, current percept shows that vehicle queues exceed a predefined threshold. So, this is the action it can take. Then there are pedestrians because of the marathon. Traffic flow is reduced during off peak hours and so on. So, this is what it's supposed to do on the regular day. During marathon, the scheduled event causes certain lanes or roads to be closed or pedestrian flow surges around a marathon route. Accordingly, it can take those actions. And whenever it detects the flow of emergency vehicles, in that case, nearby intersections are reported with increased condition due to emergency routing, then it can synchronize signal timings with the neighboring intersections to optimize the traffic flow, etc. So, for three scenarios, we can have different current percept and action rules as well. So, this way, a simple model based reflex based agent can work out on the traffic signaling and it can solve the problem. Thank you.